So thanks again for joining. And a little bit, we're going to see today an introductory overview of Safran Risk, right? And the main idea is that Safran Risk is an integrated cost and schedule or scheduled risk analysis in your desktop. Now, Safran is and that's where we like them very much, is that because it's the preferred software for project control professionals who are searching for the tools to manage complexities and risks and uncertainties. With this, I really like the product. I love the product, and what we're going to see today, we're going to make the product, make Safran Risk run through 3 use cases. I'm going to explain the use cases in a minute, and I think that will be more than enough for this hour or these 45 minutes. Right? A little bit about us, the Ferryfield Group. We are what we call a platinum partner of Safran. That means that we have some we have commercial responsibility. Sam is the commercial responsible for the US and Latin America, and Doug, who's not here today, and he's responsible for the Middle East for Safran Risk. And also we are certified trainers, so we are responsible for the certified fundamentals training as well, and for doing this type of events. Right? So we are always in sync with Safran and try to expand the reach of their systems. Yeah. So the use cases for today, we're going to import a P6 file and perform some sensitivity analysis on it, and to see how you can easily take a file that the file that I'm going to use has like, I don't know, 50 or 60 tasks, but we've been doing this with a customer in Singapore, and the ones that they have 11,000 tasks, and it's exactly the same. Maybe the performance time, instead of being, I don't know, 5 seconds, it takes 30 seconds, but we're talking about 11,000 times, so it's really neat. Then we're going to do a CVS, or a cost breakdown structure analysis only file, meaning that, and maybe this is something that you didn't know, but Safran Risk can run cost analysis on their own, meaning that you don't have to have a Gantt chart. You don't have to have a P6 file. You can just open the file, the cost, and run the analysis. And finally, we're going to do an integrated cost and schedule risk analysis. So these are the 3 cases that we're going to run today. Knowing that, again, our objective is to build an integrated quantitative risk analysis, right? So we're going to talk quantitative all the time, right? And we're going to learn how to add duration to schedules, adding risk registers, capture cost, right? And generate distribution graphics, scenarios, sensitivity analysis, etc. Right? Now, what is the framework that we're going to use? The main framework is this, right? We have uncertainty on the one hand, which is this. This is the natural oscillation, right? Admit, Daniel, as I said, right? Here you go. Thank you, Sam. This is the natural oscillation of a variable, right? It could be, I don't know, time, productivity, etc. And then we have the risk events, right? We have the risk event in our risk register, right? I imagine that all of you have played with that before, right? And this is something that the software comes with. That means that you don't have to worry about model all these things. These things, they come with the software. You will see that we can set up uncertainties. You can see that we can set up risk events. Right? That's one. And also, the software comes with this, right? And this is the typical risk management phases, right? Why? Because the software will come with the inherent or the pre-mitigation configuration. You can have, or you can add actions to it, to the risks. And you have also the residual or the post-mitigation phase embedded into the software. That means that, again, you don't have to worry about the modeling of this. The software comes with it. Okay, so that's a good thing, because these are, of course, well-known models that people would like to replicate, and sometimes replicating that would take, I don't know, 80% of the time, just knowing that the model is not wrong. And maybe with this, you will gain all this productivity, knowing that the model is always going to be the same and it's not going to break. So this is why I really love this product, right? And of course, I will share with you this, so don't worry, because it has like 37 slides, but I normally use 3 or 4. And all of them the rest are for you guys. So thank you for joining today. So let me show you Safran Risk. Safran Risk is a Windows application, right? It doesn't, see here, Hello, Daniel. Hello, Sandro. Thanks for joining today. It's well, perfect timing because you didn't hear who we are, but you're going to see what we do, and that's a good thing. And then you, in the recording, you can rehearse the other portion. So first use case, we're going to run 3 use cases. The first one is going to be open a P6 file. So for that, we go here to import external project file. So it's a docs.xar file. So I open that from here, right? You have this one here. I read it. It's a small file, of course. It has like 50 tasks, right? You have to set up the planning unit. You can set up uncertainties if you have the customized fields already being used, right? And you have some advanced options that we're going to do another webinar for. So you click on next, and this is going to convert this to a Safran project. So the Safran project, they finish with the extension SPX, meaning that the moment that you convert your P6 file, you don't need to import it every time, right? Unless you change it, right? If you import it, it will capture it, and you will say you want to override it. But the nice thing is, this is one of the things that I really like about this, is that let's say that you have your SPX file or your former P6, right? All the risks and the configuration and uncertainty are here in another file, right? Like this. So if you update this one here, the risk and the uncertainty, you don't have to remap them again. It is just going to recognize these IDs and the file, and the risks and the uncertainties are going to be remapped automatically. That means that if your planning team sends you a new version of your Gantt chart, that means that you can import it again, but the risk and uncertainties are going to be remapped automatically. And that's beautiful because you don't have to do it again, right? So I click on next, and this is going to generate, for example, drone example. What is it today? 10.04, right? Example. And where does it save it? So Safran Risk has an internal SQL Server database that runs in my computer, and that means that and that's why you will see that it's really fast, because all the files are going to be run in my computer, in my SQL Server. Or if you like, and this is something that perhaps if you have a bigger team or a bigger company, you can save all the files in a centralized SQL Server database. That means that you and your team can share all the different projects, and you can assign permissions for users, for groups, and assign who's going to be the owner of this project, who can see it, etc. Sometimes organizations, they like a simpler level of sharing, which is, I don't know, perhaps you have a SharePoint, and then you just save the SPX and the risk configuration files there, and then everybody can do it. So there are many different ways of doing that. Once the file, you see that once the P6 file is open, and we cover some best practices and tips during our trainings, you will have a very familiar interface to work with. Also, we have this layout manager. So if you do this, something like you say, take the Primavera layout and put it in here. So you'll see that this is going to be just like the Primavera layout, right? And if you have a bigger model, the hierarchies and everything will be respected. It works really well. And you have here, you see that we are in the schedule tab, right? Because we were here in the home, and we skip to the schedule tab because we imported the file. Once you import the file, you can manage it here. Of course, you have different views. For example, you have the outline view. If you want to change it, you can group it by any field. You can see the logic navigator, which is something. These are typical things that you have in a scheduling engine. So the idea here is that yes, we have a lot of things here that can help you navigate the project. We know that 90% of the time, the scheduling portion will be done by other team, or perhaps the same team with a different tool. You can add here, if you like, you can insert, delete, link, unlink tasks if you like, but we know that sometimes people don't do it here, but maybe in P6 or MS Project, right? It depends on the logic of the team. you have different views. You can see the typical view for the activity. You can see the resources. I think this one has resources, histograms, etc. You can play with the columns. So if you like, you can have all the versatility of a professional project management tool here, right? In only this one of the tasks, right? Which is something that I really like, because people would get very, very familiar with it. And you see that you have also filters here. So you have a complete filter management, because we know that you have thousands of tasks and you can set up different filters, right? So you see here, the activity is a hammock, but you can put activity has this text or pertains to this work package, etc. And then you can find, and you can do conditions. You see that you have parentheses there, so you can have conditions on top of that. So the management of the tasks, and with this I will finish this portion, is really, really neat. Now, once you have the file imported, normally what you would do, you would go here to the scheduled warnings here. What happens is that, and I imagine that if you're familiar with Primavera, with all these tools, what they do, they have this analysis where they check for two things. Normally, they check for the sanity, right, the health, sanity of the program. And what we do here, we check also how good and how well prepared is the project for propagating risk, right? Because this is what we're going to do, right? We're going to do, and remember, if we have our tasks here, right, one after the other, like this, right? And we're going to say, well, this task, it's also a distribution, meaning that we're going to add uncertainty to each one of them. Remember, the natural oscillation means that these tasks can extend, right? They can extend, they can stretch, right? But if they are not linked, let's say that we don't have a link there, all this extension and stretching that we had with the previous tasks is going to be disrupted here. You're going to have a disruption here, meaning that the risk is not going to be propagated, right? It should be cascading. And if it's not cascading, meaning that the main milestones or your focus activities are not going to receive that risk. And that's the main idea of this analysis, that this is going to tell you, for example, that you have lags, right? And what it says, it's a recommendation. It says, look, the lag, it's acceptable, right? And the lag duration is 1 day, but perhaps you have two options here. One is that you can accept it, right? And you put your notes here. And the other is that you can transform your lag into another task or another distribution. That's one. Of course, this is the project start and completion. It says, of course, the project start is an activity with no predecessor. Of course, it's the start, and the completion has no successor. I just accept that. Perhaps if you have a disruption in the logic, you didn't, for example, involuntarily didn't connect two phases or two work packages, etc. This is going to tell you, and this could be as long as, I don't know, 5,000 warnings. And then normally what happens is that you export this, right, to Excel, and you send it to your planning team, right? So they can improve the logic of the model. Once you have that in place, let's say in this case that we accepted everything, right? Once you have that in place, we're going to do a simple sensitivity analysis, even though I know that my calendar has, I don't know, 40 or 50 tasks. What I normally do, and this is something that we always recommend our users to do, is to try to add, imagine that you have all these, let me see here, let me change this. I think that this import check was it, right? You have all this logic, and what you want to do is you want to see if you apply the same distribution, the same uncertainty to all the tasks, whether you have 50, whether you have 5,000, the model responds correctly, meaning that you don't have a big disruption, right? And this is what we call a sensitivity analysis. So what you will do, you have here what we call project risks. And in project risks, you can add two things. You can add uncertainties. Remember the framework, right? Uncertainties and risk events. And you can do that from here. So you see we came from schedule to schedule warnings. Now we go to project risks. So there are two ways of doing that. What I can do is I can define a new uncertainty here. If I say new project risk, for example, and I say this is going to be an estimated uncertainty, meaning that it's a natural oscillation. You see, it has 100% probability, and it has impact in schedule only because this is not a resource loaded schedule. And for example, I say this is going to be relative, meaning that depending on the duration of the task, this is going to be applied for every one of the tasks, let's say 80 to 150%. Right? This could have costs, and you see here, here's the formula. You have actions that have duration, costs, right? And you have schedule impact in the action, and then you have, you see here, the impact because of the action. So that means that you hire somebody else, or you generated something, I don't know, an alternative way of construction, things like that, that are going to generate, remember, the pre-mitigated and post-mitigated, and then the actions. In this case, I don't have any of that because I just want a sensitivity analysis, basic one. I'm going to show you then a model that has already all of that. So I would say yes, I will add, let's say, example uncertainty, like this, or let's say basic uncertainty, like that, and I have it there. So how do I map, and you will see that in the next one, how do I map this uncertainty to all the tasks that I have, right? What I can do, and you see that this is the risk 001, and maybe I will call it uncertainty 1, estimated uncertainty 1, because this is an uncertainty. And then I go to risk mapping here, and here I have all the hierarchy, right, that I had in the previous page, right? So my hierarchy from here, from schedule, is going to be reflected here, the same one. And you can filter, and then you can find the task however you like. And what you will see here, and I will show you in a minute all the capabilities, is that for each work package or for each hierarchy element, right, you can set up if it has uncertainty or not. So what I can do is I can apply this to everything like this. And this is the type of scheduling that I will apply to each and all of the tasks of my in this case of my project. And this is what I'm going to do. I'm going to apply all of this. I'm going to say all of these are going to be between 80 and 150% with a most likely of 100. So this is, as you can see, it has a bias, it's skew distribution, and I'm going to run it. As simple as that, because this is the simplest way of taking a look to the quality of a schedule, right? And I say, let's do 1,000 iterations. You see, I just have one uncertainty because I can turn it on and off, and you will see how. And do a step through. A step through, if I run it, it's going to show you what happens. You see, I do next step. I mean, you can see, you see the start. You can see the duration as well. Everything changes. You see, take a look to the durations here. 680, 639, 671. You see, and everything changes, meaning that the project is complying with what I wanted this to be, which is to replicate the conditions under everything, I mean, considering every task uncertain. You see? Now, if I click on complete, what's going to help me with, this is going to generate, right, the complete simulation, right? Of course, what happens? So this is the complete simulation applying the same distribution. That's why it's a sensitivity analysis. But also I have, well, the start date was the same. That's why you have a box there. But you have the duration as well. So now you have two variables, the finish date and the duration. But what's the nice thing about this is as we add the duration to all of them, this uncertainty duration, so we can have, and we can drill down and see only the design portion or only the construction portion, you see? Or you can go down and see, you see, assemble fuel system and all that, you see? So the nice thing about this is that automatically, and you don't have to worry about this, you will have the capability of drilling down the hierarchy of your Gantt chart automatically every time that you run a simulation without having to wait for it. You see, it's very simple. Right? If we have, for example, focus activities here, meaning that you have milestones or special activities you want to be considering, again, you can just put it there and that's it. Simple as that. Also, you can see the iteration data. If you're willing to, or if you're interested, you see that you have all the duration, right, for the design, right? But I can change it for the whole project if I like, right? In the iteration data, if you like. Otherwise, we come back here. Now, a little bit of this, remember how this works? You have a histogram, meaning that the x-axis here is going to be the total, in this case, the total duration. That's the variable that we're reviewing today, right? Between 620, and you see here the mean and the max, you have the statistics panels, between 620 and 7, like from a year and a half to 2 years, let's say, right? Now, if your project, let's say that the target of your project was to be finished in 650 days, right? Take a look here. This is the one that I did, 650 days, right? So what happens with that? I only have 4% probability of finishing before that duration, right? That means that if I offer my clients to finish the project in 650 days, I only have 4% probability of complying with that. That means that I'm in a really bad place, right? I have in a really bad place, and maybe I can negotiate, right? What's the nice thing about the QRA, quantitative risk analysis? I can say, let's negotiate and let's go to 690 days. Right? Of course, they will like something in exchange, but at least now you have 44% probability of making it happen. It's not the best scenario, right? But at least you win like 40 days and say, look, we're going to have a month and a half of delay, and so give me 690, or please give me what will be a good advice, right? Let's take 715. 715 is 81%. You see, it's here. It's the green one here. So that means, yeah, you will be in a much better position if you do it with 715 than, of course, with what was the number? 650, 690. Why? And why is it important that you run the simulation? Because without that, you cannot get these probabilities. So if you're going to negotiate, imagine just with this very simple exercise, we didn't add any, well put uncertainties. We didn't have any risks register or anything like that. This is a 5 minutes analysis before the meeting. Who knows? We already know all of this. What else you can get from there? You can get the drivers. And the drivers, you see that it says, which are the risks driving the finish date? We don't have any risk yet. But which are the activities driving the finish date? And this we have. And you see that the main activities are, I don't know, the tender process contracting. This is for a drone manufacturing facility. So fabricating the camera, reconstruction on site, finalize the design, etc. So this is the correlation between each one of these variables, right, and the total. Meaning that if you want the model or the project to have some impact, you will have to impact these variables, right? You don't have to impact this because these have very little impact, right? This is one analysis, and then we have a second analysis, which is called sensitivity analysis, but we will be able to run it when we have risk impacts, right? Now, this is process number one. You see, we generated this analysis, we generated the drivers. Now we know where should we put all of this. And what I'm going to do before opening a file that already has this finished, right, is what should you do if you want to add risks? And what should you do if you want to be a little bit more productive, right? Because let's say that I have 5 or 6 projects, and if I want to add all these risks here, I imagine that you will have between, I don't know, 40 or 50 risks each. In each project, imagine you have to do this by hand every time. Of course, you can import it from Excel, right? You can export this little risk here. This is going to generate a template, and then you can take your files and put it in the template and import it. Safran Risk is a tool that has integrated all of the different formats using Excel sheets. So that's a good thing because that means that you don't have to do everything by scratch. There's another tool, which I really like, called the global risks here. And what it does, I'm going to go there. And what it does, it lets you have like the master repository for the uncertainties and risk. So every time that you have a project, you don't have to worry about, for example, the 3 levels of uncertainty of the company because they are already there. Right? So you don't have to think or go to the risk people and say, you remember which were the events or which were the uncertainty levels that we're going to use? Why? Because you already have it here. Or for example, you can do uncertainty by phase and say, well, this is the uncertainty that we're going to use in the preliminaries, this is the design, etc. So it depends on how you want to run it. And you can have both and the people can choose, right? So LO1, remember, this is a drone manufacturing facility. So, and here, you see that these are estimated uncertainties. Here you have risks, standard risks. These standard risks, they have another feature, which is they have a probability of happening. We didn't have this in the others, remember. The first ones were the uncertainty, were this, and the second ones are the risk events, which are this, right? They have probability of happening. And for example, you have I don't know, subcontractor liquidation. And this is what happens if you apply this risk to some people or to some tasks, right? You have to set up, in this case, the schedule impact. Let me see if you have, for example, in this case, you don't have a post mitigation. Maybe this is part of the project. And then you can set up all of these risks, right? You can have a discrete distribution. You can have, you see, a uniform, normal, beta, log normal, split triangle distribution, right? Which are bad weather, procurement, changing strategic, etc., etc. So that means that you have plenty of different risks to choose from. So how do you do it? Because imagine that you have this central repository, right? You're the risk management team, and then you set up this central repository. So you go to project risks. You see this little global risks connector, right? That basically says, pick the global risks from here. So instead of you having to write them down, you just do it like this. I want the high uncertainty. Click and click. I want the medium uncertainty. Click and click, like this. I want the low uncertainty. Click and click, like that. The same thing for the risks. I want this risk to be there, the contractor liquidation, the governance risk, merger acquisition, etc. Right? And now you have a much richer matrix, right, with risks and uncertainties. So the next step would be you go again to mapping, and you will see the changes in mapping. You see, because now you have more uncertainties to choose from. You see that you have radio buttons there, meaning that to a certain task, you can have only one uncertainty type. And you can do things like this, right? You can say, the preliminaries are going to be high uncertainty, the design is going to be medium, fabrication is going to be low because we're experts, construction is medium, testing is low, on-site reconstruction is high. You see, now we add the uncertainties for each one of them. Okay. Plus, you have this for the risks. So you can say, and where this should happen, for example, contractor issues, you can have that here, let's say in the design additional camera lens, for example, here. Governance could be in the finalized design and in the preliminaries. I'm just making this up, of course, right? Governance could be in the contract, merger acquisition could be here, you see? And you can apply the risk to the whole work package, or you can do it by the tasks, like this. You see? And you have, I don't know, here in construction. So what happens is that even, for example, let's say in the scope of work and contract, let's see that we have 2 risks. You will have everything here in this list, the uncertainty of the risks, but also you can take a look to the multiplicative effect of the schedule impact. So take a look here. You have from 80 to 150% of the duration because of the uncertainty, plus the governance, plus the merger acquisition, which means if it happens, this task can last from 7 to 60 days. And we're talking about the scope of work. Can this be real or not? That's the nice thing about this, that you can have a previous simulation where the simulation is going to tell you if this can be real or not. Let's say this is too much. So what happens if I take out the governance risk? Take a look, from 7 to 18 days. So perhaps the governance risk is very, very high. So I can come here, go to the governance risk. You see that this is in absolute values, not discrete, not relative, meaning that whatever the dates that you have there, this is going to extend the dates in these dimensions, right? Should we use it or not? Of course, it's up to you. Right? So once I have the mapping, and now you see the operation of the software, right? You take one uncertainty, you take one risk, you profile it here in the project risks, and then you go to the mapping, you map it out. Of course, I can say here in the filter, fuel, and I have all the fuel. So I want this risk, the merger, the contractual, because it's a really bad contractor. So I have all these risks here in the fuel, and I can take out the filter, and that's it. So these risks, the filters that you applied in the schedule section are going to be applied here as well. So if you have 10,000 tasks that you filter to 500, only the 500 you will see here. Okay. Now that we have a new mapping, we can do a few things. One, of course, let's run a simulation again. Let's run a simulation again so you can see it, right? Like this. I run 1,000 iterations. You'll see that it's really fast. And you see that now the project goes from 600 days to 840. Remember that before it was like 700 something. But you want to compare it. Let me eliminate the target from here. So you want to compare it with the previous one. And you want to see the effect of some of the risks and the whole risks in the total project. So for that, you can do something that's called the distribution comparison. Here, I'm going to clear it. And what I'm going to do, I'm going to run the model. And this is something I love. I'm going to run the model, take a look here, using all the risks and uncertainties in the pre-mitigation phase. Right? I will run it, which is the one that I had, right? And I will say, I want to compare my finish dates, and I will send it to my comparison like this. Right? So now I'm taking a look to the finish date. Right? My P, let's say P80. Let's see that P80 is the one that I gave to my customer, right? So this is base plus risks plus uncertainties, right? Now what I can do, I can go back to analyze and say, I don't want to see any risk here, only my uncertainties, like this. And then I run the analysis again. I'm not sure how big is going to be the difference. And I'm going to compare it like this, take a look. And this one here is the base plus risks only. You look, so now you see how powerful this tool is. You see that in 30 minutes, we were able to set up a model from scratch that had no configuration whatsoever. Of course, we took a lot of heroic decisions, right? But the good thing is that this tool, as I told you in minute number 3, has all of this built already. So in that case, that means that your base plus the risk plus the uncertainty, your P80, right? Let's say the amount of security that you want, right? You will finish on July 3rd. And if you only have risks with, I'm sorry, it was base plus uncertainty. Here you go, yeah, it's uncertainty. This is going to be at 25 days in difference. It's almost a month. So adding risks to the model would translate in a month. That's basically what you can say. Of course, you don't need to send or show this graphic. You can always copy this graphic and paste it in a, I don't know, in PowerPoint, something like this. You can do it like that. Or you can export, right? Export it as an XML, import if you have some additional reports as well. But this is the nice thing about this, that you can compare at any time. This is like a sandbox where you can compare things, right? What else you can do? And this is something that I couldn't do before because I didn't have any risk. Now I have risks, right? So I can run what I call a sensitivity analysis. I will do in P80. You can change all these percentages as well. And what it does, it's called single pass. And this single pass takes the complete project with all the risks, and then it takes the first one, runs it, and see what's the marginal add for each one of the risks, then takes the second risk, takes it out, run the model, takes the third, the fourth, etc. And it translates this into days, right? Which is something that it's really, really helpful because it says the high uncertainty estimate, this is the one that's causing in this case, the highest impact on that. But remember, and this is something I just realized, remember that I didn't have any risks included here. So let me include the risks. I'm sorry. I'm running again. You see that now the good thing is that the operation, the mechanical operation, it's very simple. So if I go to sensitivity analysis, run it again, and now you see what happens, right? That the high uncertainty is still the biggest one with 45 days, but the governance risk is responsible for 23 days of the total risk, right? This is 5 days for the uncertainty low, etc. So if you want to focus your efforts and if you have limited resources, as we all do, right, I will put my attention here, right? I will bring my attention here. So that's a really nice thing about that. Now, what else you can do? Because I know that we have like 20 more minutes, so I'm going to do it in 10, so I have a little bit for time for questions. I'm going to close this project. I'm going to open a project that has resource loaded. That means this is the same project that I was using, but it has more risks configured, and it has resource loading, meaning that you will have time and cost. So you see it in the risk mapping, has more risk. You have 5 here. You have only 3 uncertainties. And I'm going to run the model again with all of this. You see that if we configure the mitigation pre and post, and we can turn on and off the risks, you can have many, I mean, you can have hundreds, potentially thousands of scenarios here where you can say, well, this is the effect of this risk, this is the effect if we do it like this, or you can change the way of doing things. And you see that, of course, I run the simulation now that it's resource loaded, and now I'm going to have cost here. You see, take a look. So now I have costs. So the nice thing about doing that is that you can compare both, and you can do negotiations with your customer, both in duration and cost. So what if you said to the customer, well, or maybe to your internal team, that you're going to finish this in 300,000, right? So that means you have 65% probability, right? I'm sorry, 55% probability here, right? That means that it's a little bit more, it's a little bit better than the other that we started with, right? You have, of course, now that I go to the sensitivity analysis, I can do this, you see, with all the risks that I had before, you see. If I go to the drivers, I can see which are the risks that drive more the finish date, but also I can see the risks that drive more my cost, you see, which is different. We cannot assume that the magnitudes of the change are the same. So we can say here for the finish date and for the cost, the activities driving the finish date are not the same as the ones that are going to drive the cost more, right? Because of the resources and all that, right? So we have an additional dimension. So remember, we have the dimension of duration, finish date, etc. We have the risk and activities and uncertainties, but now, and that was in time. Now we have time and cost, right? And that makes the analysis really complete. Right? And you can do everything that we did before, the sensitivity analysis, right? For example, here I can run the sensitivity analysis on the finish date, the duration, and cost, right? So I can run it again. Right? And you see here that the design specification change will affect in 13 days to my project and $400,000 to the cost, you see? So you have days and then you have cost. And this is something that normally you're not able to do. You have 2 different teams doing that. In this case, you can do it together. And there's something that, and with this I will finish, I really like, which is the scatter plot. So in this scatter plot, let's say that we have duration in the x-axis, 600 days more or less. And in the y-axis, I have the cost. And let's say the cost was, let's say, $350,000. See here, right? Like this, you see? So what it says, and this is something that I really like about this, when you have resource-loaded schedules, is that, for example, what are the probabilities finishing in less than $300,000? So I will have to do all of this, right? Everything below. And it will be 58% plus 9%. So it's 67%. 67% probability is that I finish in less than, I'm sorry, in less than 350,000, which is this value here, which is okay. But what happens if I said to my customer that I was going to finish in 600 and, I don't know, 40 days? That means that if I want the model to finish in less than 350 and in less than 640, I have only 22% probability, right? So that's in a worse position than before, because I said that these were my limits. The nice thing about this is that the negotiation that we started doing only with duration, then with cost, now we can do it in both. Again, we cannot assume the same shape of the distribution for the cost and the duration. Last thing that we could do, well, we have this probabilistic cash flow as well. That means that you can have, let me see here, there's a lot of things going on here. So let me show you only a few. So it's clearer, but the main idea is that you have your S curve, in this case, your S range, right, of the project. So you see how much you were going to spend in each one of the months or the years, right, with a P20 or a P80 or a P90. So that means that if you're the CFO of the project, you will have to have all this money in the bank at a certain level, maybe P75, so you can cope with all the expenses from the model. And then you have this critical path map, which is basically, let me make this bigger, right? Which is basically showing during the simulation with this criticality index, what was the percentage of time during the simulation that the task was part of the critical path. So all the ones that have one, that means that they are critical path, whatever it takes. And for example, you have this one here, the fabricate engine, that was not part of the critical path, but only 6% of the time. So perhaps you don't have to monitor this task as a critical task, right? Only because the others are 100%. Of course, you have a 94% here, so maybe this is worth it to be considered as a critical task, right? So as you can see, and what I will owe you is the cost breakdown structure, because that will take me like 10 or 15 more minutes. But the main idea was to show you what a life cycle of a risk management process would be using Safran Risk for a P6 file. Remember, what we did is we added first the sensitivity analysis, added the risks, run the simulation, and then the mechanics are pretty simple. That's why I really like the software, because you don't have to worry about things working. You just have to worry about things being well configured, and that you basically don't add garbage or rubbish to the model. So with that, I will open the floor to questions. I'm not sure if you guys have some questions